Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. This is the second in a series of videos on the 2017 Toyota Prius Prime. If you saw the first video in the series, we removed the battery from the vehicle, and I have the empty battery housing right here. And we are going to totally reassemble the battery and look at all the individual pieces, how it's wired, and how it works electrically. So let's get started with that. If we look right here in the bottom of the case, we can see there are 5 slots for what are called battery stacks. And so we have 5 stacks of 15 lithium-ion battery cell packs for a total of 95 lithium-ion battery cells. And of course, all of these battery cells are put in series with each other. So if you take 95 cells, multiply that by 3.7 volts nominal voltage per cell, we get 351.5 volts. Now that's the nominal voltage. That is not the fully charged voltage, which is really close to 4 volts per cell. And then the fully discharged, as far as this car is concerned, down around 3.48 volts or so per cell. All right, so before we can put the battery stacks in, there is a battery heater that goes across here, and there are 5 battery heaters, one that fits underneath each of the cell stacks. So let's go take a look at that battery heater on the workbench over here and see how it is wired and learn some unique things about that heater. So the battery heater is this big one-piece assembly. And as you can see, there are 5 rows of heater grids that go underneath each of the 5 battery cell stacks. So the first thing you need to understand about the heater is that there are actually 2 heater circuits. There's 2 electrical connections here that provide power and ground and have a thermistor, a temperature sensor, for each of the 2 circuits. Now the 3 battery cell stacks on the passenger side of the vehicle have their own heater circuit, and then the 2 on the driver's side have their own heater circuit. And from what I read, we have 2 separate heater circuits for diagnostics. If we command both heaters on, but we see from the temperature sensor that only one of them is working, then we can set a trouble code for a heater circuit problem. And so that's the purpose of the 2 thermistors here, is to diagnose whether or not the heater circuit is working as it should. The heater elements themselves, if we zoom in real close here, so we are starting on the rear of the center heater, which is for cell stack number 3. If you look, you can see a copper wire that is woven into this pad. And actually there's 2 circuits in parallel with each other in this circuit here. All 5 of these heater circuits have a different woven pattern in them. And I can't find anything that explains that, but the only thing that makes any sense to me is that maybe each cell stack needs a different amount of heating based on the position of it within the battery housing itself. Maybe the outer ones are cooled better than the inner ones, which means the inner ones are heated better because they absorb heat from the surrounding area. I just don't know. But anyway, the 3 heater circuits on the passenger side of the vehicle comprise a giant series circuit, actually 2 giant series circuits. If we were to follow these circuits, we start with the power and ground at the electrical connector, and then the power connects to the 2 circuits on the driver's side of battery heater number 3, and it goes down, makes a loop, comes back up on the passenger side of battery heater 3, and then we've got a yellow and a white wire that transfer that same series circuit into battery heater 2. It goes down, makes a loop, continues with the same series circuit, battery heater number 1, and then back to the ground. So we have power on this one, ground on this one. There are 2 series circuits actually in parallel with each other that make this giant loop. And the total circuit resistance of these 2 series circuits in parallel with each other on battery heaters 1, 2, and 3 here is 1.78 ohms at 27 degrees Celsius. And that allows our 12-volt battery, which is being charged to around 14 volts while your plug-in battery charger is working, to apply 14 volts to these heaters, because this is a low voltage circuit, and that will give us 7.86 amps of current. And if we take 7.86 amps of current multiplied by the 14 volts, that gives us about a 110 watt heater combined with all 3 of these. On the driver's side, we have power, the positive connection here on the right, the negative on the left, and it just makes a big single series circuit with a loop in each heater, and the resistance of this series circuit is 5.95 amps, and that gives us 83.4 watts at 14 volts. So once again, not much heat. Now, if you recall from the first video on removing this battery, and we talked about the plug-in charger and how that worked, remember this heater only works while the plug-in charger is installed or plugged in on the vehicle, and only if the battery temperature sensors here indicate that the battery temperature is less than 2 degrees Celsius, which is around 35.6 degrees Fahrenheit, it will turn on these heaters, and it'll leave the heaters on until it reaches 5 degrees Celsius or approximately 41 degrees Fahrenheit. So this doesn't do a lot of heating, but in cold temperatures, at freezing temperature of water, well, a little bit above 35 degrees or 2 degrees Celsius, it's going to heat the battery while charging, because when it's cold, they don't like to accept a charge. Okay, well, let's take this battery heater and install it in the battery case over here. There are 4 little plastic clips that hold it in place per heater element, and so I'm going to bring this over and let's get that installed right now. Okay, so we'll bring our battery heater in, set it in place. There are several clips, 1, 2, 3, 4, right there, that hold it in place in the front. And then there are 1, 2, 3, 4 little clips that hold each element in place. Okay, now that I've got the battery heater installed, and once again, this is all one piece, one part number, we are ready to bring in each battery cell stack and bolt them down to these big studs at the back and at the front of the battery. But before we do that, let's take a look at these stacks in detail and see how they are configured, how they're wired together, and how we would do any type of service and diagnostic work on them. Okay, this is one battery cell stack from the 2017 Toyota Prius Prime Battery here. This cell stack has 19 individual cells, lithium-ion battery cells. This entire stack right here, it has a sticker on the end that says it is rated at 1.76 kilowatt hours. 1.76 kilowatt hours. And then we have 5 of those. So if you take 1.76 and multiply it by 5, you get 8.8. But the label on the top says 8.79. So there must be some rounding up issues here. The entire battery, according to Toyota service information, is rated at 25 amp hours. Now, each of these cell stacks has its own negative and positive terminal. Each cell stack, though, the polarity is opposite because each cell stack is put in series with the one next to it, so that all the voltages add together. And that's the same as adding all of the individual cell voltages together that are put in series here. So we have 19 individual lithium-ion battery cell packs in here that are all put in series with each other. So if we take 19 cell packs and multiply that by the nominal voltage of 3.7 volts that they are rated for, that gives us 70.3 volts nominal per cell stack. So I've got a multimeter here. Let's measure this. I'm just going to, some of you may be thinking 70 volts is going to hurt me. It will not. According to OSHA regulations, if you look that up, it refers you to the NFPA document 70E, which tells us that we must wear personal protective equipment for anything 50 volts AC and above and 100 volts DC and above. Well, this is a DC battery. And as a matter of fact, I could take 2 screwdrivers here, back probe these terminals, and touch negative and positive. It does nothing. I can't feel anything. Anything less than 100 volts DC, and you are okay not to wear PPE. However, many automobile manufacturers in their own service information, to be extra safe, require that 50 volts and above you wear the PPE. And I'm sure that's not going to hurt anyone, but that's one of the reasons we have a service disconnect lever on almost all of these batteries, is to reduce the DC voltage and reduce the chance of getting shocked. Now, once we put all these in series with each other, we'll exceed the 100 volt rating. So let's see what we really have for voltage here. If we're 70.3, is that what it was? 70.3 was the nominal voltage. So this is our positive terminal right here, and our negative right here. I'm back probing, so I'm not damaging any pin fit. Won't damage any terminals there. And our multimeter is reading 69.6 volts. So we have, once again, basically a 70 volt stack times 5, 350 volts, 351.5 volts nominal. As I mentioned before, when these are fully charged, these are pretty close to 4 volts each. I think they were 3.98. If we multiply that by the 19 cells, that would give us 75.6 volts, still not above the 100 volt range. Okay, before we take a look at the rest of the components here of this battery, I always get people that want to know, how much does this battery weigh? What are the dimensions of the battery? Because there's always somebody that wants to find one of these from a salvage yard like I have and use it in their solar wall system for storing energy to charge their vehicle. So I've got a scale right here. Let me turn this on. And I'm going to sit this up here. And I am getting 16.9 kilograms. 16.9 kilograms or 37.2 pounds. So 16.9 kilograms or 37.2 pounds. So 16.9 times 5 gives us 84.5 kilograms of total battery stack cell weight. And then we have the battery case and the cover and the heater and the contactors and wire harnesses and other things to add weight to that also. If we do it in pounds, 37.3 pounds times 5 gives us 186 pounds of battery cells, and that gives us 186.5 pounds of battery cell stack weight in addition to all of the others. So I do not know what the total battery weight is. I forgot to measure that before I took it apart. But in this video today, we will put this whole thing back together and pick it up with my crane scale and see what the entire thing weighs. I'm guessing that it's around 250 pounds with everything installed, which is pretty lightweight for a battery, but it is only 8.79 kilowatt hours of a battery as well. All right, let's take some physical measurements of the dimensions of this battery. So not counting the brackets that hold it down that you can unbolt, we are 23.5 inches, which is 596.5 millimeters or 59.69 centimeters long. And then the height of the whole thing is approximately 4.75 inches or 120.6 millimeters or 12.06 centimeters. The width of the battery is 6 inches or 152 millimeters or 15.2 centimeters. Okay, and then of course there's these brackets on the end here that you can remove the bolts and remove the brackets. Okay, we've looked at the positive cable and the negative cable here, which is the overall positive and negative terminals of the 19 cells that are in series with each other. There are some covers that go over the individual cell connections that I will take off next, so we can see those. Okay, we can see along the top here the individual cell connections. If I tip this on its edge here, you can see those connections. So we have the positive terminal right here. Straight across from that is the negative terminal of the exact same battery cell. And then it has a connection, a little bus bar, just like the previous Toyota Prius batteries, that goes over to the next battery cell's positive, where it goes over to the negative terminal of that cell, and then it has a bus bar that goes to the positive of the next one. And we just serpentine back and forth all the way down the line there. These are just little 8mm nuts. It took about 5 Newton meters of torque to remove them. I can't find the torque spec on them because they're not serviceable. So on battery stack number 1 over there, I removed all of the nuts and took off this bus bar system. And the bus bar system has individual voltage monitoring circuits that run down the edges of the bus bars here to measure each individual cell's voltage. And if you look at these, this picture of a scan tool, data list, you can see an example of that. So once I removed that entire bus bar assembly there, which by the way, it has 6 temperature sensors in it. Let me see. 1, 2, 3, 3 temperature sensors. One on each end and then one in the middle to measure battery temperature. And so the 3 temperature sensors have 6 wires that connect at this little connector right here, and then all 19 battery modules have their own cell voltage monitoring systems that connect at this electrical connector where it plugs into the battery ECU, or the battery monitoring system, to keep track of individual cell voltages and set trouble codes if necessary. Now these are cells numbered 77 through 95. So 77 would be clear down here on the negative, and 95 would be clear over here on the positive. If we take a multimeter and measure across each individual cell, we should get approximately 3.7 volts nominal. I'm getting 3.664 volts on this one. So it's just a tiny bit below nominal voltage. But that is, it could be anywhere between 3.48 volts and 3.98 volts from what I've seen, or somewhere approximately in that range, depending on the state of charge. Which, by the way, if you ever want to ship a battery, you are supposed to discharge it down to its lowest recommended voltage level before you ship it, to reduce the chance of any type of incident, I guess is the proper term. All right, now running down the center of this battery stack is this big white piece right here. This is the battery vent, and the battery vent is there in case of an overheating or overcharging, which causes overheating event that causes the battery cells to expel gas. And that gas is required by law to be expelled outside the vehicle. So that gas would come into this tube here, go over, and there's a big manifold that connects all 5 of these battery stacks together, and then goes out the back of the battery down through that little tube through the bottom of the trunk, hatch trunk area, and vents outside the vehicle. The actual airflow that cools the battery comes in on some tubes. Let me grab one of the tubes here. So we saw on the back of the battery there were some vents in the first episode. We saw that there were some vents where 2 blower motors, one on the right rear, one on the left rear, blow air into the battery. They blow it into this little plastic piece right here that is sealed up against, let me turn the battery around so you can see it. So this air inlet, where the air comes in, goes up on the side of the battery cell stacks here, and goes in these little grooves here, and then that forces air to come in this direction, but then it goes through the cells straight across and then out on the other side here, where there's these little deflectors that point it towards the front of the battery. So this is the back of the battery, this is the front of the battery. The air blows towards the front, where it can go out the sides of the front of the battery and out the little flapper doors, the one-way flapper doors in their left and right rear fender areas, and blow that air outside the vehicle. Okay, so this is battery cell stack number 5, but number 4, 3, 2, and 1 are just like it, with the exception of the polarity is opposite. positives here on this end, negatives here on the next one over. So when they're wired together, they just have short little connections to put all of these batteries in series with each other. All right, let's get these battery covers back on, the cell connection covers. Like, now that we've seen the cooling system, let's put the ducting back on. And we'll turn this around and get ready to show you how these are all wired in series with each other. Before I do that, though, I need to put the ducting on the other 5 battery cell stacks. So here is battery cell stack number 4, number 3, number 2, and number 1. Okay, now that we've got all the air ducts connected to the battery cell stacks, I want to show you one thing if you're ever tempted to disassemble one of these cell stacks yourself to help you avoid some major aggravation. Okay, if you've watched any of my other videos, you know that I like to disassemble things that you're typically not supposed to disassemble. And usually that's not a problem. It doesn't cause any damage and I don't get hurt. But I disassembled this battery stack right here, and I almost damaged it, and I almost got hurt. And so I want to warn you, if you buy one of these from a salvage yard and decide you're going to take it apart, you better be very, very careful. If you unbolt all of the bus bars and take this off and get the vent off, you'll see all the individual cells, like in this photograph right here. And then right here at the front of the battery, or well, actually on each end of the battery, are some rivets. So on this battery here, there's a rivet here, there's a rivet here, there's one down below it, and one down below over here. So there's 4 rivets that hold these big metal straps that are insulated with this white plastic piece from touching the tops of these battery cells. These 4 straps hold all of these cells together, and they are compressed. And I thought, hey, if you look over here, I'll just drill out those rivets and then make the strap hole a little bit bigger, put some threads in the plate that it bolts into, and I'll be able to take it apart and put it back together whenever I want. So I did that. I drilled out the rivets and tried to slide these straps off, and they are extremely tight. There's a huge amount of compression that these straps are holding in place. And once I popped them up, the ones on the bottom down and the ones on the top up, the end of this battery, well, the battery grew probably 50 millimeters, a couple of inches longer. And when it did that, these 2 straps that are not insulated on the ends came very close to touching the positive and negative terminals of this first battery cell that was there. And they are electrically connected on the back side here. So that would have shorted out that battery cell, which I don't know what that would have done on a 3.7 volt cell, but I suspect there's enough energy there that it would have caused some it would have caused some problems. So I took some insulative caps that I have for high voltage wires and put over those and insulated them, and I was able to get it apart okay. And if you look at these photographs here is an individual cell, and then here's the plastic heat sink pieces that go in between. They're actually nylon, and from what I've heard, there are some nylon materials out there now that conduct as well as, if not better, than aluminum. And so these plastic separators cells are actually transferring heat from the battery cells themselves into the air that is blown through them to cool the battery. And so you can see pictures of the separators with the flat side on one side and then the grooves on the other for the air to blow through. Well, that was all fun and fine, but then when I go to put this back together, I could not, at least by hand, compress it enough to get these straps even close to going back in place. And so I had to get some of those big long carpenter's pipe screw clamps like you would use to clamp a bunch of blocks of wood together if you're trying to glue them together or do some carpentry work. And it took a clamp on each side to compress this down just barely far enough that I could get these straps back on and get the bolts in place. And I don't think I want to take that apart again. I like to do stuff like that, but I was really glad just to be able to get it back together. So just be warned that if you take it apart, you need to insulate these these straps so they don't short out the batteries. And then be warned, you're probably not going to get it back together properly, if at all. So I don't know why you'd want to take it apart anyway. But anyway, now we are ready to connect all of these together in series with each other and show you how it is wired inside of the battery case, and then we'll put it in the case. Okay, I've got all 5 battery stacks 1, 2, 3, 4, and 5 right here. Let's see how they are wired together with the service disconnect lever, with the high voltage fuse, by putting everything in series with each other before we bolt it into the battery housing itself. So on battery stack number 1 right here, we have our negative cable, and that will connect to cell number 1. So on the scan tool, when you monitor the cell voltages of 1 through 95, number 1 is over here, number 95 is clear over here, and they're just in series. So battery stack number 1, cell 19, has a positive terminal that's going to connect to battery stack number 2, cell 20's negative terminal. So we'll connect those two together right there. Now we've just taken a 70 volt battery and put it in series with another 70 volt battery, and we are above the 100 volt safe level for DC voltage, and I have my personal protective equipment on, my high voltage gloves that I have tested. Now, the other end of battery stack number 2, which has cell number 38 in it, has its own battery positive terminal right here, and it is going to connect to battery stack number 3, cell 39's negative terminal. So those two clip together, and then cell number 57 here of battery stack number 3, its positive terminal connects to cell 58's negative terminal right there. And then on the other end of battery stack number 4, we have cell 76 with its positive terminal that will now connect to battery stack number 5's cell 77, except these two terminals don't plug into each other. Instead, they plug into the high voltage fuse. So this high voltage fuse is going to connect battery stack number 4 to battery stack number 5. And if I take the cover off of this, you can see the fuse in there. I believe it's a 250 amp rated at 450 volt fuse. This is a serviceable fuse if for some reason there's a short circuit somewhere that causes this to blow, like in an automobile accident. If one of the high voltage cables got pinched during an accident, it should blow this fuse. And then you replace the cables and replace the fuse and perform diagnostics and make sure everything's okay. So I'm going to put the cover back on this fuse here, because that's one of those things that you don't take apart. You just replace the fuse. You can see this nut right there that holds it in place. Replace the fuse housing rather than the fuse itself, but it has two electrical connectors on it that are going to allow us to connect battery stack 4 positive to battery stack 5 negative. Right there. Okay, then battery stack number 5's positive cable and battery stack number 1's negative cable, these two should give us the 350 volt total battery voltage. So if I measure from the positive terminal of battery stack number 5 to the negative terminal of battery stack number 1, right there. If everything was wired in series with each other, our multimeter would be reading 350 volts. But as you can see, it is not. It's reading pretty much 0 volts. And that is because we have not installed the service disconnect lever. Now the service disconnect lever comes over here and connects battery stack number 2 to battery stack number 3. So our service disconnect lever connector, which is right in the back of the battery, we saw it in episode number 1 of this series on the Prius Prime. So as we plug in the service disconnect lever, we just push down, rock it in place, and then snap it back in to connect the interlock circuit. And as you can see, it is reading 348 volts. Now if I come back to the service disconnect lever and remove it, then our voltage drops back down to 0, as it should. The next piece that's involved here is the battery ECU, or the battery monitoring system. And as you can see, there are 5 electrical connectors right here that allow the wire harnesses from each of the 5 battery stacks, these harnesses right here, to plug into it so it can monitor the individual cell voltages. We won't plug that in until everything's back in the battery housing. And then we have a set of contactors. This is the hybrid battery junction block number 1, and there are 2 of these in this Prius Prime battery. So this entire battery junction block is for the negative side, the negative cable of this battery. So the negative cable from the battery itself connects right here at the top of this junction block. And then the high voltage cable, the negative cable that goes up to the inverter under the hood, connects right here. And so we have the battery connect here, the inverter connect here. The job of these contactors, these relays, is to connect those two together under certain conditions. Now the negative contactor, this one right here, is there to connect the battery to the inverter when the vehicle needs to move down the road, to go into the ready mode. This contactor here is for the charger. So when you plug in your external charge cord, whether it's AC or DC, to the outside of the vehicle, AC only here in the United States. There's the possibility of DC quick charge outside the United States. It will connect the battery negative terminal to the charge terminal here, rather than the inverter terminal. And then we have a pre-charge contactor pre-charge resistor. We have a charger pre-charge contactor, and we use the same resistor there. And the job of the pre-charge contactors and resistor is to prevent the capacitor in the inverter assembly, the smoothing capacitor, from charging too quickly, giving a surge or a rush of current that could actually damage the contactor points as they are closing. They can actually arc. And so by running it through a resistor here, and this is a 30 ohm resistor, it slows that down, allows the capacitor to fully charge. When that capacitor in the inverter is fully charged, then the voltage on each side of the contactor contacts is the same, and so there's no voltage differential, and the contactor can close without any arcing. So in other words, the job of the pre-charge contactors and the resistor is to save the life of the contactor itself, the main contactor. So we have a hybrid battery junction block for the negative terminal. By the way, this has an additional electrical connector here that connects to a thermistor to monitor the actual temperature of the physical blade, the terminal of the negative contactor, where the current from the battery goes into that contactor. They monitor the temperature of the contactor terminal to make sure it's not getting too hot. There's also a service port here where we can connect up a discharging machine to discharge the battery, or even to charge the battery with an external machine on the negative side, and there's one on the positive side as well. So this is where battery cell stack number 1's negative cable is going to attach. Right there. And then it just sits right there. And then we have the equivalent for the positive side, the positive terminal of the battery, and I've removed the contactors so you can see what they look like. The bottom, they're like giant relays, except they're contactors to handle more current. And there's a positive contactor and a positive contactor that connects the positive cable of the battery from cell stack number 5, cell 95, to the big heavy wire that goes up to the inverter underneath the hood. And then there's the charger contactor that connects the battery positive terminal to the charger, whichever one you have. There's also underneath, inside of this housing, which I did take apart, if you look at this photograph here, a fuse built into this assembly. And it's a 30 amp fuse. If that fuse blows, this thing will not allow the charge to work. So this is in the charger circuitry here. If for some reason there's a short circuit between the charger under the back seat and the wiring that comes up here to this assembly, that fuse should blow. And then you have to replace this entire unit. This also has built in right up here a current sensor, so we can monitor the total current leaving and entering the high voltage battery itself. It also has a temperature sensor to monitor the temperature of the actual metal terminal of the positive contactor. We also have a service port here, and just like on the other hybrid battery junction block, we have control circuitry right there, and oh, it's just right here on this one. There were 2 sets of control circuits on the other because of the pre-charge contactors, but just the powers and grounds to activate the relays themselves. All right, so this is where our overall positive cable from battery stack number 5, this one right here, is going to come in and plug in right there, and it just sits right here. All right, and then the only cables that are left over Now that we don't have connected are the 5 big electrical connectors for the battery ECU, and then there is one additional small electrical connector for the temperature sensors in all of these batteries. So remember, each stack has 3 temperature sensors. However, battery stacks 3 and 4 have one more external sensor that measures the temperature of the battery vent tube gases, if there is any there. That is what connects there. All right, well, let's bolt all of this into the battery housing next. All right, let's start in the middle with battery cell stack number 3. Here comes battery cell stack number 4. Number 5. Number 2. Sure, all my wires are out of the way. And number 1. Okay, we are ready to bolt down these 5 battery cell stacks, but I just remembered that there are some brackets that go down in between each cell stack that I can't access with these cooling ducts on that I installed on the workbench. So I just need to take those back off, and then we'll get the bolt down brackets. By the way, you may have noticed I don't have my gloves on. Everything's disconnected, so we're down to 70 volts apiece, and I'm not going to put them on until we reconnect everything in series towards the end here, because it is about 85 degrees here in the shop, and with those gloves on, it's very, very hot, very uncomfortable. Okay, these are the 4 brackets. They're called the number 1 hybrid battery shield reinforcements. They go down in between each of these sets of cell stacks. There's a stud in the housing, the lower housing, that these rest up against, and then we bolt them down. Looks like 1, 2, 3, 4 bolts per bracket. Okay, we have 4 nuts per cell stack, and then 5 bolts per bracket in between each cell stack. Let me get all these installed and torqued to specification. Okay, now we've got all that bolted down, we can put these intake ducts back on. Okay, as you can see, this is a very packed, tight fit, everything in there battery. There's not a lot of room for anything else in there except for an upper inch or so of room for the computers and contactors and fuses and service plug grip and all of that. On the other end of those cooling ducts we just installed for battery stack number 4 and 3, there are 2 temperature sensors that plug in to those cooling ducts that we just installed. Okay, the next thing we need to install is what's called the number 1 hybrid battery pack wire. This whole assembly right here has the low voltage connections to connect outside of the battery with everything inside the battery. So we've got our big connection to the hybrid battery ECU. We've got our connections to all of the individual heaters, and then the connections to the positive contactors and the negative contactors right here. So let's get that installed next. It just goes right here in the front of the battery underneath all of these harnesses. Like that. And then there's a number 1 hybrid battery protector that goes right there. And then all of these bolt in place. Okay, in the back of the battery, to connect to all of these battery vents, in case the battery overheats and gases, there is this number 1 hybrid battery hose, it's called. And it's basically just a big manifold that connects all 5 battery stacks to the one single exhaust outlet on the back of the battery that we looked at in the first episode of this series. And if you look at this photograph here, you can see where it comes out and goes into the floor. So this is installed next, along with all of the vents that connect the cooling ductwork to the outside of the battery housing. So we've got all of these ducts where the air is going to blow into these inner ducts and then through the battery itself. Okay, so now we sit down our duct hose, which is our vent for gassing, and then it has 10 little clips that hold it in place, and then at the back of the battery we have the exhaust duct where it guides those gases into the floor. So we've just got these 10 little tiny clips that hold the ductwork, the vent ductwork in place. Okay, now that we've got our intake ducts where the cool air comes in to cool the battery, all installed, and we've also got our ventilation ductwork in case the battery gas is installed, where it goes out the center back there. Now we can install some inner supports, some inner framework here, the number 1 battery frame and the number 2 battery frame, as they're called, that go over the top of these cells to help give it some extra support and some places to bolt down our contactor assemblies, our high voltage battery junction blocks, our battery ECU, and our fuse and our service disconnect plug. Oh, by the way, I forgot to mention in the very first video in this series that there's a big warning in the Toyota service information warning the drivers of this Prius Prime, that this battery is in the back of your car, and this is not a sealed battery, meaning that it actually says, do not carry large volumes or large quantities of liquid in the trunk, because if it spills, it could fill up enough of the trunk hatch area that liquid could get into this battery. And it's DC, so it's not going to hurt you, but it'll hurt the battery. It'll ruin the battery. So read your owner's manual. There's a big warning there. Do not put large quantities of liquid in the trunk hatch area that might spill and damage the battery. Okay, so we've got 2 of these big support frames that we need to install. So we've got one on the driver's side that's going to fit right in here, like this. We won't bolt these down until we make the electrical connections here inside the battery. And then there's the other one for the passenger side. So we can't bolt these down until we get all of these wire harnesses routed where they are supposed to go. So here on the passenger side of the battery, we have the temperature sensor harness for battery stack number 1 that needs to plug into our low voltage harness here. And then there's just a little clip that holds that in place. There's another temperature sensor harness here for battery stack number 2. Temperature sensor for battery stack number 3. Looks like I should have plugged all these in before these brackets went on. Temperature sensor for battery stack number 5. That goes right here. And number 4 goes right here. So we've got our temperature sensors, stack number 1, number 2, number 3, number 4, and number 5 all connect to this big harness that goes to the battery ECU. All right, then we have our battery heater harness connector. It's going to plug in right here for the heater circuit on the passenger side, and another one over here for the heater circuit on the driver's side. So now we need to route, before we can put those brackets on, the cell voltage monitoring harnesses. So we've got 5 of them right here, right there. We also have to make the series connections now between these batteries before I can put those brackets on. So let me get my high voltage gloves back on. Okay, next we need to route these voltage monitoring circuits. So let's get the bracket on the driver's side. We'll just set it in place because there's some clips that go certain places. And all right, so we've got a monitoring circuit from battery stack number 1. It's got to come in here. Battery stack number 2. Stack number 5. That's quite the puzzle. Okay, so I think I've got it figured out. Make our series connection between battery stack 3 and 4. Our series connection between battery stack 1 and 2. Right there. We've got our monitoring circuits all tucked away in brackets. Now I think we might be ready for these battery frames, the official name. Okay, let's try this again. All right, now we've got a bracket over here on the driver's side for the high voltage fuse and bracketry for the battery ECU. So let's get those on here next. All right, so our high voltage fuse is going to go right there. Our battery ECU is going to fit right there. And then we've got battery ECU connections right there. And we've got a ground wire right there. Then we have all of our voltage monitoring circuits. So battery stack number 5 comes in right over here. Battery stack number 4 is this blue one right here. Comes in right there. Battery stack 3. Battery stack 2. And finally, cell voltage monitoring for battery stack number 1. I believe we are ready for the next battery frame. Okay, so now we have our hybrid battery junction block number 1 for the negative side of the battery, and number 2 for the positive side of the battery. Right there. Our negative connection from the battery will clip in place right there. Our positive cable is going to clip in place right here with a couple of cable clips to hold it in place. Now we still have a bracket and connections to make here on our service disconnect plug, our service plug grip. So here's our service plug grip bracket. Right there. And our service plug grip socket. And connection between battery stack number 2's positive and battery stack number 3's negative right there. Just like that. And we've got all the nuts that will hold down all of those I need to install and torque. And then we've got one more piece, the battery heater relay goes right here. And then of course we've got all of these low voltage harness connections to make. Alright, so this looks like the positive junction block connections. And the current sensor last. So we've got the current sensor connection, the temperature sensor connection, the control circuits for both relays, and that's it on the positive side of the junction block. And then on the negative side, we've got a connection that goes all the way over to the service plug socket for what's called the interlock circuit. So the interlock circuit is just a 2-wire low voltage circuit that detects when the service plug has been removed. Sometimes it detects when the cover of the inverter has been removed, or when a high voltage connection at the transaxle or the inverter has been removed as well. So that's our interlock circuit. And then we have the negative contactor side connections, where we have the controls for the big contactors and temperature sensor, and then a connection for our relay, our battery heater relay, and then a connection for the controls for the pre-charge contactors. Okay. All right, we've got everything assembled here except the nuts that hold down all of these parts I just installed. So let me get those installed, and then we will put on the top cover, and then we will lift this thing up and see how much it weighs, and then we'll be done. Okay, it's time for the upper cover. The upper cover has 20 bolts and nuts that hold it down. Okay, we've got the top cover on. The only thing left here are the front shields and the service plug grip and its cover. Right here, you can see the front of the positive side hybrid battery junction block and the negative side, where the two big heavy cables come in from our inverter converter and go right here, and the two charger cables come in and go right here. So let's get those covers on, and then we'll lift this thing and weigh it. Install the service plug. Make sure we clip it in place so that the interlock circuit is connected. And then on the front, we put on the center shield first. Come on. There we go. And then the driver's side one to access the low voltage connections. And then the passenger side one to access the high voltage connections. Just like that. There's a hole right here for what's called a battery cover lock striker. This little orange piece of plastic right here. This is removed with the handle of the service plug grip. You stick it in the middle here and you rotate it counterclockwise while holding this outer piece. And that is put in this hole here to prevent people from, well, in an attempt to prevent people from pulling off the high voltage cover if they're not trained properly. And then finally, the cover for the service plug grip. The official name for that is the number 4 hybrid battery shield panel. Okay, we are ready to bring the crane in here and lift this up and see how much it weighs. And then that'll be the end of this episode. In the next episode, we will get into on-car diagnostics of the contactors and the battery system, the charging system, and so on. So let's bring that crane in here next. All right, let's bring it up. I've got the crane scale turned on there. Okay, woohoo! We are reading 273 pounds, and that is 128.83 kilograms. So a little heavier than I thought. Now, of course, that includes 4 of these casters. They're not that heavy. I would suspect without the casters, maybe 3 pounds less, 270 pounds. So that is the extra weight that is in the back of the Prius Prime. I believe that is about 200 pounds heavier than the Prius of the same model year with the lithium-ion battery. But if you went to the previous nickel metal hydride battery, that's probably about 150 pounds heavier. But, of course, we get electric vehicle range out of this also, more than just a mile on a good day. So this has been the reassembly of a 2017 Toyota Prius Prime Battery. Thank you for watching.